Okay, here we are with number 6. I wrote it on a separate sheet of paper because my work took up the workspace for this. We're given tangent. We need to find sine and cosine. And we also need to remember that sine is greater than 0. Y'all know that just means it's positive. So if sine is positive, but I have a tangent value that's negative, then you can deduce that cosine of theta has to be a negative number. All right, let's go ahead and figure out what's going on here. So remember, what is tangent? Tangent is sine divided by cosine. So tangent of theta is -8. Let's plug that in. And what must we know about sine and cosine? It must be a positive number. And remember, it almost has to just be written as a whole number. Sine is -8, cosine appears to be a 1. Remember, -8 divided by 1 is -8. But based on this information, these are not the correct answers. Those are wrong. The correct answers for this, 8 is positive, cosine is negative. So the correct answers for number 6, sine of theta is a positive 8. Cosine of theta is a -1. Those are the correct answers for problem number 6. Okay, let's go ahead and continue. So remember, that was the answer for this problem right here. I showed too much work from this problem, so make sure you write that down. Okay, let's go ahead and look at the next part down here. Very important, very foundational, very crucial, very much needed to be successful in this unit. We are going to start factoring trig expressions, and it is just like regular factoring, just regular factoring. Don't let, sine and cosine scare you, just regular factoring. Look, you have two terms here. What can you take out of both of these terms? The word cosine's printed twice, so let's go ahead and take cosine out. And remember, cosine is just to the first power. So we're going to have sine squared of x, and that's it because we took that out. And remember, when you take all of something out, a 1 is its placeholder. And you can always double check by distributing this back. Cosine times sine squared is going to be sine squared cosine. Cosine x times the -1 is negative cosine x. But you are not done. That is a difference of squares. This can go further because it's squared. That exponent is the same exact thing as x squared. Now remember, a difference of two squares is going to be sine x minus 1 and sine x plus 1. Don't forget to bring down your GCF from the previous line of your work. That is the complete factored form for this expression. All right, let's look at problem number 2. Right off the bat, you need to recognize problem number 2 is for sure a difference of squares. So number 2, there's two cosines in the problem. We're going to put a cosine here and a cosine here. And remember, it's going to be -1 and +1. That is completely factored. Let's look at problem 3. For problem 3, it is factored the same exact way as our warm-up. Sine squared is like x squared. And then this is 3 sine squared. That's like 3x and then -10. Remember, we factored that earlier. We're going to factor this trigonomic expression exactly the same way. So you have two sine values. Let's draw parentheses. Put a sine x in each one. What are values that multiply to a -10 but combine to make a -3? It is going to be a -5 and a +2. And that's it. It is it. You should check to see if you can factor further. You cannot. This is in complete factored form. All right, number 4. I'm stuck with number 4. You cannot factor anything unless it has the same trig functions. You can never ever do a secant with a tangent. So it appears that I'm stuck. However, you need to check your identities and see if you can write one of these in terms of the other, and you can. Look right here. See this secant squared? I can rewrite secant squared just like that. So, let's do that. Remember, secant square root of x equals tangent square root of x plus 1. Use substitution. So, let's put this in for that. So, tangent square root of x plus 1. Now I'm going to recopy the rest of the expression. Minus tangent of x minus 3. Look, we have a plain 1 and a negative 3. Plus 1 and a negative 3 is going to be a negative 2. So let's go ahead and write our highest exponent first. So it's going to be tangent squared of x, that's like x squared, minus x minus tangent x. And remember, a positive plain old 1 and a negative 3 is just going to be a negative 2. That's what we're going to factor. Think about this in your head. Is that factorable? Oh, hold on. Yes, now it's factorable. Is that factorable? Yes, then this is factorable. Let's draw 2 sets of parentheses. There's 2 tangents here. Put each tangent in its own parenthesis. What are factors of negative 2 that combine to make a negative 1? It is going to be a negative 2 and a positive 1. That's going to be the factors for that. And that is how you factor those trigonomic expressions.